So let's talk about this. First of all, you guys are all in Texas, right?
Yes, sir.
Where the weather is, they say the weather is not very nice. Is that right?
Still a little cold.
You guys know where I am, right? You know what part of Hawaii I'm in?
No.
You know, with the beaches and the water coming in, Waikiki and all that. I'm just kidding.
Yeah, I was like, you're from Texas.
Yeah, I know, I am. All right. Well, I just thought I'd try to make you guys laugh a little bit because I don't like this weather. I'd rather it be warmer, but here I am. Okay, so solving this problem. This one's pretty well designed where you're going to get the x by itself. To get the x by itself, you got to add 3 to both sides.
Professor,
Yes.
I'm here, Yulissa.
Lissa Dorado.
Yeah.
I'm here
Anyway.
too, Harry.
Now, I asked all the folks just about, do you work, Yulissa?
Oh, do I work? At home, mainly during the weekends.
You used to email me like every other day. You're the midnight zombie, right?
Yeah.
You stay up till your day starts at midnight. I know.
Basically.
All right. I want to be very careful because I don't need a lot of emails at 1 a.m. Ding, ding. All right. So you're good. Where do you work online at?
Pardon me?
You said you work at home or something?
Yeah, I work at home during the weekends. I do my dad's paperwork.
Wow. Good for you.
Yeah.
All right. Let's move on then. I got you marked in. So
I'm
one
here
thing,
too, Professor.
huh?
This is Sherry. I'm here.
Oh, Sherry, I just told everybody you must have won the lottery because you didn't.
Yeah.
Good to
That's
see you.
her.
I got you in.
Thank you.
All right. So look, with any problem, you want to get x by itself to solve it. So you got to add 3 to both sides. Now, remember, when you square the left, you got to square the right. So x equals 49. That's pretty basic, simple one there. We've got a lot of territory to cover today. Same thing is going to happen for problem number 2. The square, you get x equals 9. Now, you always need to test the answer, though, because there's no such thing that give you -3, so it won't work. The square root of 9 doesn't give you -3, so we call that an extraneous answer. Just remember that. So sometimes you can get a mathematical answer, but it just doesn't work. Number 3, and these get a little bit more complicated. Number 3, I'm going to do this. I don't know why, but I will. We're going to do x minus 7 equal to 2 times the square root of x plus 1 all under the radical. Let me see if I can do this one. You can see it. Sometimes when I do them on the board, I think they make more sense if I can print nicely. So we have x minus 7 equals 2 times the square root of x plus 1. Let me see how the book does it. The way I would do it, it'd be, I think is, let me check on this one. I don't think I do it that way, but we'll see. Yeah. Yeah. Okay, yeah, I'll do it their way. Okay. Back to the whiteboard. There's really not a shortcut for this one. It looks like there is, but they're not. So you have x minus 7 equals 2 times the square root of x plus 1. Now, You could divide both sides by 2 and square it, but that's more complicated for this group, I think. So we're going to do this. We're going to square the left. We're going to square the right. Now, when you square the right, that's supposed to be the easiest thing. So whatever is in the radical you get by itself, that's x plus 1. Then you got to square the 2, that becomes 4. So that's why you square the right. Now the left-hand side using FOIL becomes x squared minus 14x plus 49. Now that's because you take x minus 7 twice, like this. Multiply it out. X times that gives you the x squared. This gives you a minus 7x. This gives you another minus 7x. 7x and 7x gives you the minus 14x. Then 7 times 7 is 49. We're going to multiply the other side out, so we're going to get 4x plus 4. Well, we want to get it equal to 0, so we're going to subtract 4x from this side, goes away. So that gives you minus 18x on this side. We subtract 4 from this side, so it's going to give you a plus 45. And that makes it equal to 0. You factor this. X minus 2 numbers multiplied together have to add up to 18 and multiply to 45. Are there any guesses out there? Well, it would be x minus 3 times x minus 15 equals 0. These two numbers have to multiply to equal 45 positive. They must add up to 18 inside the 2. So that means x is either 3 or 15. Why? Because it makes it equal to 0. 3 minus 3 is 0. 0 times anything is 0. Does that make sense for you all?
Yes.
Yes.
You should keep this is the FOIL process. So you should be good. This is hard, but not that hard. You just have to keep all your ducks in a row and keep them, make sure you see and add correctly. I think they give you this, and then they tell you that one number doesn't work. I think 3 doesn't work. And on the test, I'll let you know if you need to check them out. I'm happy if you get the 2 numbers, 3 and 15.
Dr. Wickman,
Yes.
I'm sorry to interrupt, but Maria Alvarado is asking if you received her email.
Yes, but tell her I didn't accept it. No, I did. Yeah.
Okay. All right. Thank you.
Thank you.
I'll tell
Yeah.
her. Thank you.
Just kidding. I like made a smile. All right. So the next one. 4. Solving this one again is the same thing, except for you want to get the square root by itself, and they do that by subtracting the minus 5. Now notice line 4. You have x minus 5 squared. And on the right-hand side, you square x plus 7. Now, you're doing this on your own. Your brain's telling you to do this. Why? Because you're trying to get x by itself. You certainly can't get x by itself very well with a radical like is on the right in 4th line. But once you square it, you get whatever's inside, which is x plus 7. For the other side, you get x squared minus 10x plus 25. And you want to get it set to 0, so you subtract x, becomes minus 11x. Subtract 7, you get 18. That factors. Now, pretty soon they're going to give you one. You got to use the quadratic equation. Again, you get 9 or 2, and you test them out, and 1 didn't work. That was the 2. Here's a cube root. Let me just do the cube root one for you, because believe it or not, it's really easier. And it's 2x plus 1 equals plus 5 equals 0. So let's do this one. And I don't mean to be taking your evening by doing these, but I think, again, sometimes it's better. So the cube root, you can see the mistakes I make then. 2x plus 1 plus 5 equals 0. So we're going to push the 5 to the other side so we can get this cube root thing by itself. So we get the cube root of 2x plus 1 equals a negative 5. If you cube this side, you get whatever's inside. 2x plus 1. Then you got to cube this side, which is equal to a negative 125. Then you get 2x equals negative 126. Because you're trying to get x by itself, you subtract 1 from both sides. Divide both sides by 2, you get x equals a negative 63. And that's what you get. Pretty easy steps there. I hope you understand them. I should have said if you cube the left, you cube the right here. Boom. That's what you do. I did it in my brain, but it didn't show you. Questions about the cube? No different than any other one. You want to get the x by itself, so you got to cube it. For the next page. And they said negative 63 worked out, so that's good. This is the most difficult problem of them all on the test. So notice in following the book, because it's a little bit complicated for my writing, and I can't get it all on one screen usually, but look. You have 2 square roots on one side, so you're going to push 1 on the other side, and then take the 1 on the right, so you have 4 minus the square root of x plus 5. That's technically the second line. It's the third line in the book, but it's really, they just rewrote the problem. So they're going to square the left. You can see the red 2, get whatever's inside, x minus 3. But when you square the right, this is where students just freak out. For some reason or another, they can't do these. You have 4 minus square root of x plus 5, and you multiply it by itself. That gives you 16 minus 8 plus x plus 5. So this part on the right-hand side, practice so that you know how to get the 16 minus 8. In fact, let me just do that part for you because that's the hardest part. There's no doubt about it. That's where the students sometimes, most of the time, all the time, oftentimes have challenges. So let's take a look. Trying to make this a little humorous for you, but I guess I'm not trying to make it a little interesting. So here we have the hardest part. We said we have in parentheses 4 minus the square root of x plus 5. And since that's squared, it's going to multiply by itself again. 4 minus the square root of x plus 5. So in FOIL, you're going to take this times this, gives you 16. Then you take this times this thing, and you get a negative 4 square roots of x plus 5. You take this again, you get the same thing, another negative 4 square roots of x plus 5. And then you get a negative times the negative of the last two things, which means you're going to get a positive, you get whatever's inside, x plus 5. Then you add like terms, 5 and 16 becomes, what, 21. You get a negative 8 square roots of x plus 5. And you get the plus x. I think that's what they get. Take a look. There it is. You see you have negative 24. Now all we did was the right-hand side up here. What you can see right now, let's see if I can push it up. We did this first line on the right, 16 minus 8 squared plus x plus 5. Now, that's the top line. We did the right-hand part. Once we have the right-hand part done, we're going to get x by itself. How do we do that? Well, what they did is they took away x on the left, so you can take it away on the right. Added the 5s, then they're going to put 21 on the other side, so you get negative 24 equals to negative 8 square roots of x plus 5. Divide everything by negative 8. And then they get 3 equals the square root of x plus 5. You square the left, you get 9. Square the right, you get whatever's inside. Get x by itself. Boom. X equals 4. So 6 is the same thing as 7. The same exact sort of concept. 6 is a little bit longer, a little bit more detailed. 7 is the same thing, except for in 7, you get an x squared minus 10x plus 21. Use FOIL. It's the only difference. And you get 2 answers, and then you gotta try them both. So that is on the test, that one. So I want you to be very critical of it. 8's the same thing. No sense in doing all these. It's just make sure that you know how to do that one. Now, we didn't do this one before, the concert one.
No.
Okay, so somebody came up with a formula. The formula says the sound, that's this formula right here at the end of the paragraph here, S equals 21.9 square roots of 5t plus 24.57 under the radical. Now, T stands for not time, but temperature, believe it or not. And so they want to know if S, the sound was at 1170, I don't know, decibel root, what the temperature was. So the first thing they do is divide everything by 21.9 to get that square root by itself. The square of the right, you get whatever's inside, 5t plus 245.57, 2457. Again, when you square the right, you just get whatever's inside. There's no math really to it. The left is something, though. You have 1170 over 21.9. Now, when you have 1170 over 21.9 and it's squared, you have to be able to use your calculator. So let's see if we can get 2854.2. Let's just practice. This, again, I want you to get confidence using your calculator. My calculator is asleep right now, so we're going to wake him up. There we go. We're going to take, in parentheses, we have to open it up because it's a 11.7, 1170. We're going to divide it by 21.9. The close parentheses, we're going to square all that. So we have to upper arrow it to push it out. So that's exactly what you see. Now you're practicing doing that, making it look like you see is the hardest part, and then you just hit enter. You get 2854.19, and that's what we got. .285.4.2, you can see that's the third line from the bottom. They subtract the 247 from both sides to get t by itself. They get 397.2. Divide it by 5, you get 79. So the temperature outside is about 79 degrees. Question about this one. These are wonderful problems on your test because they're so easy. You just plug in a number. The formula is given. Like I said, in the old days, we had to calculate that formula. Jeez. All right, moving on. So the next section we're supposed to do is the 6.7.
Yes, it's page 408.
Okay. Let me type it in. All right, here we are, page 408. Applications, a computer screen. This is kind of an interesting one too. With a computer, actually TV as well, I didn't really realize it until somebody kind of figured it out for me, is that they make it sound like a 21-inch TV is really 21 inches, but if you measure across, it's really only 18.3. I said, well, how come it's only 18.3? This is because they measured diagonally. I said, wow, sounds bigger. So this is just a Pythagorean theorem. A squared plus b squared equals c squared. You put in two parts of the puzzle, 18.3 and the 21, you got to get a squared. So you square the 18.3, which gives you 334.89. Square the right, you got to get a squared by itself, so you subtract it. That number from the right, you get 106.11. Take the square root of the right, because you have to take the square root of that, you get 10.3. So that means it's only 10, it's a small screen. Questions about Pythagorean here?
No.
No.
One in numero section dos or dos two. 7 squared plus 4 squared equals c squared. I mean, gosh, we're never. So look, I'm not even going to waste your time on number 2. Not going to do anything on number 3 because it's all Pythagorean stuff. Okay, now here is a construction problem. This is more. It's going to be Pythagorean theorem. We have 12 feet, 16 feet, and we want to know d. So d is obviously the what? C squared. So you're going to take 12 squared plus 16 squared to get d squared. Let's see what they do. 12 squared plus 16 squared. The distance of c is the square root of 400. And if you didn't know that, just put it in your calculator. Oh man, I got 400, but I don't know what to do. Well, you just gotta hop on your calculator again. And you look for the square root, which is obviously above x squared. In the blue, anything in the blue, you got to hit second. Here comes your square root, and we put 400 in there. Push it out so we get the answer. Hit enter. Boom, 20. I mean, these are, if you get these problems on the test, you should be like, well, by a lot of it's pretty good. You guys be all right with that. But I don't think it'd be but one problem like that. All right, next page. One more of these, a garden page or something. What you have here. Hope it doesn't lock up. Oh, the road pavement measures. Oh, this is reading the letters. So the formula said the letter size in this form was 0.00169d to the 2.27 power over h. They give you h is 4 and d is 180. I mean, they gave you every part of the puzzle. So here it looks like that's what you got to put in your calculator. You just put it in your calculator. You got to make sure you know how to do it. Now it looks like this when you finish putting your calculator. Otherwise, you won't get 5.6. Good one to practice. I'm not going to waste your time and do it because I'll put it in parentheses. Start out, and then end it in parentheses, and then divide that by 4. You guys, you want me to do that one so you can see how to do that one with the calculator? Anybody?
Yes. Yes.
Yes, please.
Yeah, this is a little bit different because you have to add an extra parenthesis. Excuse me. 2.27. So you can see the problem there. In order to make this work on our calculator, stop this here. We're going to go to it. And I don't mean to oversimplify things, class. I'm sorry if I come off like that. I just want you to feel confident that you can do it. That's really what I'm trying to convey. So the first 0 is not needed. I'm going to start out with 2 parentheses. 0.000, that's 3 zeros. 169. And I'm going to put that end parenthesis here like that. Then start my other parenthesis, which is going to be the 180. The reason I start with 2 parentheses is because all of this is going to be over 4. So it has to read the top line as one thing. And the only way it's going to do that I think Maybe I got it wrong. Let's see. We can go back. Thinking. Well, let's see if this will work. 180, close parentheses. Upper arrow. No, we can't close it because we have to do 180 to the upper arrow. This might not be right. I might have it wrong. Let's see here. This is to the 2.27. Push it out. Now close my parentheses. I'm thinking that this might work, but then I have to close parentheses. And 1, 2 open, unclosed, and closed. And divide all this by, I think it's messed up. We'll see. I'm trying to figure out how the computer will read it. Is that what the answer was or not? It wasn't, was it?
I can check.
Is it?
I'm sorry, it's taking a while.
Yeah, I know that feeling. It's still not right. Did you find out if that was right yet? You still there?
I don't see the answer.
Yeah. So we got 5.56. Let's just take a look because I think of another way to do it. But let's see. It'll be right there. Okay. 5 point, yeah, we got it. 5.6. There it is. Got it to be right. I put my parenthesis behind the second one because it has to read it all as one. We got 5.6. That's exactly what we got. So if you just put it in like this in the calculator, I don't think it'll work. I have to use those parentheses. Let me do it one more time just to make sure you feel comfortable about it. Let me write down what I think the solution should be in terms of calculator first. That way I have it. If it's right. Let's see. So again, let's see if it works again. I don't kind of wasting your time, but I just kind of like to make sure it's right. I want to say anything and say, yeah, I was right. Then so look, you can see the top one was right. We had double parentheses. We're going in the same direction. That's probably what I should have done. It's just let you see the top one. You just keep deleting this one because this is. But anyway, you can see I had two open parentheses, one closed one, another open parentheses, and another closed one. So you have two opens reopens. Should have the same one number and then closed again. It read it as a double, but anyway, here's the way I would do it again if I were to do it over. I don't like putting the things there. Okay, I'll get that. Oh, heck. Let's clear it out. Let's just give my whole history. All right, so I said I would do it this way, open parentheses. I put in my point, 3 zeros. 1, 2, 3, 169. I would we'll just start out with another place. It'll bring to like a unit, 3 and 2 and 1. Then I'm going to put a parenthesis here, which means it's going to multiply, hopefully, 180. Up arrow with the 2.27. Push it out. Close parenthesis. Nice. There you have 1 open, 2 open, and 2 closed. Divided by quattro. I think this is how I would do it. Yes, that's the cleanest way to do it. The number of open parentheses should match the closed one. It's technically correct in every way. I could have put a time sign between the 9 and there, but that automatically knows that. So that's how to do it. You should practice. There's a couple ways. The machine will give you the right answer, but sometimes it's very temperamental. Anyway, that's the way to do it. Sorry for taking so long. I want to make sure you guys are good with that sort of thing. There's nothing worse than to have a calculator and not know how to use it from the wrong answer. So 5.6 is the height of those letters. That's what that meant.
I think that was the last example for that, 6.7.
Yes. So we're going to go to the next chapter.
6.8 would be, the first example starts on 416.
Go ahead there. Thank you. Is that Lizette?
Yes.
This is a unique chapter. So on the exam, I don't know how it is possible, but students do not seem to get this one. So on the left, you see a graph. Now, the arrow from starting at the point -1, -2, going to the left, goes up. Means it's increasing. From the point 5.2, the arrow on the right line goes down, decreasing. From the point -1, -2 to 3, -2, it's constant. That's all they're telling you. And you should be able to, by the way, the 0.52 is called a relative maximum. So you should be able to see what part's increasing, which part's decreasing. Also from 3 to -2 to 5.2, it's increasing. You can see that, reading left to right. Anyway, go to the next one. Relative maximums, there's the top. Relative minimum, although it's acute, really is C better than C3. C2 is the maximum. C1, C3 are minimums. So Here you have an equation. F of x equals this. You put this in your calculator. I guarantee you're going to get this. And the relative maximum is given by the point there. And the relative minimum is given by this point here, which is 4.082, comma negative 1.604. So now, the interval in which it is increasing, you can see from the right, from that one point, 4.082, all the way up, decreasing from that other point, negative 0.082. I mean, and also from 2 to, in that middle part, it's decreasing. So you can see that. Now, the relative max is the point, negative 0.082, comma 2.004. It almost looks like 0.2. So all you're doing is interpreting a graph and knowing what is the relative max. The relative minimum is the other point right there. Does anybody have a question about what we mean by maximum and minimum for a graph? It's where the graph turns. That's the peak here, and it turns at the highest point. And here it turns at the lowest point. Next. I haven't had anybody ask any questions. I don't think I've been that clear. Okay, car distance. Nurses, you're in the yes, drive away from a hospital at right angles to each other. Kiera's speed is 35 and Matthias is 40. Here's an example of it. One's going a little faster than the other. 35 and 40. Express the distance of the cars as a function of d times t. Well, notice we have a triangle. We want to know the distance to get it far apart. So 1 we call 35t. We don't know what the t is, but we know that they're going 35 miles an hour. The other one is 40t. We don't, again, know the time, but we know that it's going 40 miles per hour. And so the distance equals time squared. So this is the formula that you have. You can see at the bottom in red. Now, we go back up, and if they give us some time, we can calculate the distance. But they only want you to calculate the formula to understand this. Again, let's look at Matthias' car. It's going 40 mph. We don't know what the time amount it is, but it's going 40 times a certain amount of time. So if it's going for an hour, it would go 40 miles at that speed. We know that Kiera's is going 35 t, a little bit slower. After 1 hour, it would go 35. So you'd have 35 squared plus 40 squared equals the distance squared, if we had 1 hour in each of those time frames. Now, so this is not a hard problem. Now they want us to calculate this without knowing the time. Now, notice they give an absolute 35t squared gives you 125t squared plus 16t squared. You add them, you get 2025t squared. So I'll give you the distance on the left. And then they take the square root of 2825. They give you 5315. Square root of t squared is t. They take the square root of it, you get whatever's inside. Except for the 2825, you have to take separately, because you have to take the square of that number. So if we take our calculator, 2825, oops, up there, take the square root, and there 28, 25, push it out. We get boom, we get 53.15. If you take the square root of t squared, you get t. Just exactly what they had. (53.15t). But notice they use an absolute value of time. Why? Because you cannot have a negative time. There's no such thing. Now, this is a very interesting problem here. This college has 30 feet of dividers, and they want to maximize the area because they have two sides of a rectangle. It's in a corner. So this is what you have. Room, big giant room, and they want to partition part of it off. So they're going to pick this corner. They have some partitions, and they want to make the size max. Want to max that space. So these two sides, this one here and the bottom one here, they're fixed. We don't have any control of that because it's the corner of the wall. But we can make these two sides vary. We can make them adjust them. So now let's go to the next step. Hope you understand that part so far. Now it says they have 30 feet of dividers. So they really should say they're in increments, but they want to know the maximum area in which to form two sides in a rectangle. So if you put them solid against the wall, you'd have 0. And this would be the shape that you would have. So at this point, 15, 15, you get 225 square feet of space. Why? Because 15 is your X, and it maximizes it. That gives you your Y. If you put 14 in there, and you put in a calculator, you get 30 minus 14, which is 16. You have 16 feet of dividers, and that would not give you the maximum space because you have 14 times 16. So think of it like this. To make it make sense, think of it like this. So we have 30 feet of these partitions. If we put it solid against the wall here, all of them, there is nothing, there's no space. So this thing starts at 0 and comes down. Now, so numerically speaking, the total of each side, the two columns, side 1 and side 2 of this corner spot, side 1, side 2, could be 0 and 30, 1 and 29, 2 and 28, 3 and 27, and you can go all the way down. They went 15 and 15. They also try 14 and 16. Now, to get the max amount of space, you multiply them out. So you could try it. You know 0 times 30 equals 0. That means there's no space in there. 15 times 15. Somebody wants to work that out real quick. We can get that answer easy enough. And we should get 225, as I said. Well, the space right below will be 14 times 16. We could try that now. 14 times 16.
24.
224. It's a little bit less. That's right. And of course, you go the other way. This gives you the maximum 15 times 15. by just using this chart. I hope that makes sense. Question about it, anyone?
No,
Yes.
sir.
030, 129, 220. These are the total number of feet is 30 feet of partitions. One wall could have all 30 of them, and it would be this one right here. This is the example right here. All 30 are right here, straight and rolled, like solid against the wall. You could push it out 1 foot. It'd have to goes down 1 foot. Not very much space. 1 times 29 gives you 29 square feet. 2 times 28 makes it a little bigger. It keeps it bigger until you get the mass of 1550. That's kind of a tough problem. That's pretty cool. And like other people would say, there's a number of ways to explain it. Now look, this is a piecewise function. X plus y is the equation. And on the right, well, this is f of x. F of x is your y. You have 3 parts to this equation. The first part is x plus 1, where x is less than -2. The second one is you have x is equal to, or y is equal to 5, but the domain is x is greater than -2 and less than or equal to 3. The second one is x squared, x is greater than 3. The old example they used to have was cell phones, but this is, and that was a little bit easier to understand. So they just changed it to this. So what you have here is 3 different equations, but it's one problem. Now, it was much better in the other book where they showed you a graph, but let's look at the first one. It says x has to be, that's your domain, -2 or less. So if you put -2 in for x, you get a -1, but it doesn't quite include -1, so it has to be everything -1 and below it. They don't show it in the graph example. I don't like it. But that's what you would graph. So again, just looking at the first line, x is your domain. It's on the right-hand side. It said it has to be -2 or less. So that means your first equation would start at -2. You put -2 in there, it'll give you -1. And the only thing it can do is get less. If you put a -3, it becomes a -2. -4 becomes a -3, and so on. For making it easier to understand, let's go down to number 3. Well, heck, they're not even asking you to do that. Let's just make it the easiest thing possible. All they want you to do is find f of -5. So if you put -5 in for this equation, since it's less than -2, you get 4. -4, boom. That's all they're doing here. If you put 0 in for it, you get what? Is 0 less than -2? No. So you can only use it for 1. That's the middle one. You get 5, 0. That's what it's showing here. So in this problem, all they want you to do, if you look in the top line, is put that in for your answer. Now, all those f of things, you have -5, -3, 0, 3, 4, and 10. You all see those numbers right there? The only places you can plug those numbers in is where it allows you in the equation. So the -5 goes in the first one. -3 goes in the first one. 0 fits in the second one. 3 fits in the second one. 4 fits in the last one. And 10 fits in the last one. Why? Because it says x has to be greater than 3 for the last one. The only one where x is greater than 3 is 4 and 10. So we put in 4 in there, you're going to get into this whole thing. This is one equation. But the 4 only works for the last part, which gives you 16 and 100. Does that make better sense to you guys? Anybody get this one? Jerry, do you understand what they're trying to do here?
Yes.
Sure. See, let's take the first number, -5. It says find f of -5. Well, you have to look on the domain parts, which is after the word 4. Where does -5 fit in there? -5 fits in the first one because it's less than -2. It doesn't fit in the second one, and it doesn't fit in the third one. So you only can put it in for that. If you put in -5, you get the answer of -4. So to 0, f of 0. Look at all 3 of those domains to the right of the word 4. 0 does not go into -2 because 0 is greater than -2. 0 fits in the middle one. So if it's 0, no matter what, you get 5. Boom. The last one, the other 2 fit in. Okay, I hope that makes sense. This is the same thing for this problem here. The domain is whatever it is, and you plug it in. You won't see 6 on my exam, but the other one will be close. I'll give you, in the review, I will give you one that makes sense. Now, here they graph it. They have, this is the problem. G of x is equal to 1/3 x plus 3. And they say x has to be less than 3. So you plug in 3. 3 times 1/3 is 1. 1 plus 3 is 4. So at 3, you start up there with that little donut hole. And y? The x is given as 3, but it's really less than that. That's why it's a circle. So you go over to the right in the graph and read 3. Then you plug in 3 for your x, and you get your y. And that gave you 4. But you know it can't be 4 because it doesn't include it because it's less than sign. Does everybody get this part here? The first part. The B.
Yes.
Does that make sense? I hope it does.
Yes.
If you put 0 in for x, which is less than 3, you get 3. Notice if you go to 0, 3, it cuts right through there. Boom. All right. Let's see, these are all the same sort of things. I don't want to make it more complicated. I think the example on the review will be good. Okay, now let's look at 8. It says here, graph the function defined. X squared minus 4, x plus 2, x cannot equal -2. Why? Because it gets undefined. Becomes undefined. So any number that you put in for the first part, the top part of this graph, I'm not talking about the 3 comma, I'm only looking at the x squared minus 4 over x plus 2, you're going to get an answer. Now notice the answer. If you put in a -2 for this, it becomes undefined. So you draw your graph and notice you have -2, -4 has a donut hole in it on that real long graph. That's the graph for the first one. Look, let's put in a number 4. 4 squared, let's put in a +2. 2 squared is 4. That's your x, 2. 4 minus 4 is 0. 0 over 4. So if you put in 2, notice where you're hitting the graph. 2, 0. Boom. Right there. 2, 0. Marked right there. Let's look at the next one. It says no matter what, y is going to be 3. That's what it says. That's the y. All of this stuff, all these formulas on the left of the comma are your y, but it says the x is -2. So it doesn't matter. It says that x -2, y is 3. So you look at -2, you get that dot 3. That's number 8. And that's the second part. It says again, 3 is y, x is -2. You have to learn how to read those. These are simply just graph them. It says here, this, if you look at the graph, you have 1 to, it's a step. It means 0 to 1, it doesn't include 1, is that. It says at 1 to 2 includes the next step. That's all these things are. So if you look at them, for simplicity's sake, look at the very, very bottom one. It says at 3. You go to right at 3. And it says x has to be greater than or equal to 3, but less than 4. So we're going to go doing the last one. So go to x is 3. We read all the way up to where x is greater than or equal to 3. So it's a dot. You read it over to right where there's 4. That's a donut hole. I just did the last one. Questions about the last part of this one? We just did one step. X was 3. We went over red 3 on the graph. And it's greater than 4. So on the x, you'll see it starts at 3 and goes to 4, but does not include it. It's the second part. The y is always what? 3 stands for what, class? The x or the y? It's got to be the y, because look, here's you're right. It's got to be the y, because look at x is greater than or equal to 3. So you go up to the x. Here's your x. 3 and less than 4. So you go up to the step, and there it is. That third step on the right. And the 3 stands for your y. X is on the right. It says x is equal to 3 or greater than 3, but less than 4. The only place that it shows that is that step right there. Where you have, it's the second step down. Third step down. Read from right to left. You have 3 steps. You're going down the steps. Does that make any sense to anybody, I hope? Does anybody get this last one? Last step? I would say that's homework then. Look at this and try to figure this out. This 3 stands for your y. Look up there, there's y, 3 on the graph. X starts at 3 and doesn't quite go to 4. That's your step.
And it's equal or less, they circle.
Right.
Or
a
actually,
circle-
they,
Yes, you're right. If it doesn't equal it, it's a circle. It's a donut hole. Is that Lizette?
yes.
So again, the y, that's the first thing. Because it doesn't say x. X is on the right. It says for x is, it says right there, for x is greater than or equal to 3 and less than 4. So you look where x is greater than or equal to 3 and less than 4. Y must always equal 3. So you go all the way up, boom. All right, that's that one. I think that's what I'll end for today. I don't want to burn everybody out. Yeah, that is the end. Let me go over one more time to see if anybody joined us. Let's see. Let me look, see, I'm missing. It's a Tiffany. Tiffany, are you here? You always are here. Tiffany Lewis. Man, that's rare. Who else do I not show accounted for? Daniel Ramos. You here? Elizabeth Romero. Elizabeth? April Sierra? Anybody else that's here that I missed? Marielle, are you here? Anybody else? . Angela, whom are you?
Yeah, I'm still here.
I got you. Is Mariella? Mariella signed on?
It shows that she's here.
Yeah, no, she's not answering. Okay, you guys are good. Any questions of me? Next class, we will do, we'll do symmetry and go from there.
Thank you.
Thank you.
All right, guys, thank you very much.
Thank you.
Thank
Bye.
you.